Hi, my name is Avril Sauter and you're watching Conducting Cisco Unified Wireless Site Survey. In this lesson, we're going to actually look at using tools to do predictive site surveys. And I want to start with a bit of a discussion about the Air Magnet Planner tool. And again, there's several tools that you can use, and this is one of the key ones that a lot of people at Cisco will use. And the reason they use the Air Magnet Planner tool is that the results from this can be imported into the wireless control system. Alternatively, you can use the Cisco wireless control system as well. And we're going to talk about that, and then we're going to do a demonstration that uses the wireless control system. Now, the Air Magnet Planner can be bought as a standalone product, or if you buy the Air Magnet Survey Pro, it actually comes as part of that tool. The advantage of using the Air Magnet Planner is that it really not only allows you to draw the building shapes like the walls and the cubicles, the doorways, etc. It has a lot of opportunity for you to select the different types of propagation and attenuation characteristics of that material. It obviously takes some time, but you can really go in and create a very detailed plan. You can put obstacles and other things in which case when you actually run your prediction of where to place the access points and what does the coverage looks like, that tool can actually produce a fairly accurate simulation. And then you can go in and calibrate this tool with actual measurements to then fine-tune this as a planning tool going forward. Of course, the one thing that you cannot predict with any tool, whether you're looking at the Air Magnet Planner tool or the wireless control system, is sources of interference. And so you can only predict the RF environment based on the walls, etc. you put in, the types of access points, the type of coverage, but interference will always affect that. So again, whenever you're using a predictive tool, they're great to give you an idea of what you might expect, of what might happen in terms of a deployment, but you can never replace the need to go out and actually do a physical survey, because you need to see what interference, etc. is operating in the channels that you plan to deploy on. Now, down in the bottom here where I've rung it round, this is the tool where you click on it and say, I want to go into the planning mode. And then what you see is you've got a map window where I can bring in my image, and this is where I'm going to generate my heat maps. Then I have the project window, and the project window is really where I'm going to be managing my project. So if I have multiple site plans that I want to go through, if I want to save them and delete them, I do that in the project window. Then I have a data window, and the data window is really where I'm managing my access points. So I can see what the channel is those access points are operating on, what the SSIDs are, etc. So it gives me my view of the access points that are on the site plan. The AP property window, if I click on an access point, this window will display the attributes of that access point. Things like what power level is transmitting at, what antenna is using. And then I have a range of toolbars, etc. that are helping me put access points on here, generating heat maps, inserting walls, etc. So enabling me to really create a prediction for my site plan. So before we look at a demonstration of the Cisco wireless control system, let's just talk a little bit about it. So the wireless control system, not unlike the Air Magnet Planner tool, also allows you to import floor plans, allows you to define the walls, the cubicles, allows you to define the types of materials, ceiling height, where you want to place your antennas, where you want to place your access points, the antennas and the directivity of those antennas. Also allows you to enter information about the clients as well. I've personally found that the Air Magnet Planner has more granularity of some of the data, like for instance the building material. I also suspect that the predictive tool is perhaps a little bit better than in the Cisco control system, because I've personally found it gives me a better projection of the coverage itself. However, the Cisco wireless control system is actually quite a comprehensive tool. And of course, if you're using it for managing your network, you've already got this tool, and rather than going to the expense of buying an additional tool, you can use this tool to get a feeling of where your access points need to be, and you can generate heat maps, etc. And we're going to take a look at that in the demonstration in a moment. Before we do that, I always want to stress is that you need to be accurate in the data that you're putting into the tool. If you're inaccurate in any way of the data that you put into any planning tool, the results will obviously not be effective. And some of the most common mistakes I've seen are people going in and putting in the wrong antenna height, or perhaps using an access point that's not the one they plan to deploy the network on. So make sure that you're as accurate as possible. It can be painful putting in all the walls, etc., but in order to get the best model, that's the best way to go. Again, you can do a predictive model without all of that detail, but the more data you put in, the more the model has a chance of actually reflecting what you might find when you go out and actually do your site survey. In this demo, we're going to take a look at the Cisco wireless control system. And this system is really used for monitoring wireless LANs after they've been deployed. However, it's got a couple of features in it that allows you to look at maps, to put on walls and obstacles, and then actually predict where your access points should be. And so we're going to take a look at this and discuss its applicability as a predictive tool for where you should be placing your access points. So let's start by logging on. So it brings us here into the main dashboard of the wireless control system. And what I want to do is I want to go to Monitor and select Maps. And this is where we're going to be able to create a map of the area that we want to provide coverage on. Now, this tool allows you to do a campus-wide environment, and underneath that you can define multiple buildings. And so we just have one building here. We'll select on that. If we come over here, we're going to go in here and select Edit Building. Press the Go button. And we're just going to take a look at what this building looks like. So I've defined it as Building A, define myself as the contact. I've said it's got 4 floors, and I've put in its dimensions, and its dimensions are in feet. Now I can change the dimensions by going into properties to meters, but I'm going to leave it in feet for this demonstration. Now what I'm going to do is I'm going to add the floor plans to this building, and when I add the floor plans, it's very important that the floor plans do not exceed the building size for obvious reasons, and if they do, it'll throw out an error. So why don't I add an extra floor here? We'll make it floor 5. Press OK. And now I'm going to come over here and select I want to add a new floor area. Click on that. Press Go. And now I can enter the details about this floor area. Now, one of the most important things here is not only must you give every building a unique name, you must give every floor a unique name. And so, for instance, if you were just to call this floor 1 or floor 2, etc., and you define the same names in building B, so you'd have 2 floors in different buildings, both called floor 1, that's actually going to cause a problem for the tool. So it's very important that when you define these names that you make sure they're unique, not only in the building, but right across the campus that you're trying to define. So I'm going to call this 5 in building A. I'll put myself as the contact. And here we're going to do floor 5. Now this is a very important, and this underpins all predictive models, and so it's really important to get this one right. What you're defining here is the type of environment that you're deploying the wireless LAN in. And if I was to choose the outdoor open space, what that means is that there's no obstacles, and so there's nothing to stop the signals. So my signals are going to go quite far, and I'm going to get quite a large cell area. And so the tool's going to say, oh, no obstacles, large cell. If, however, I choose the cubes and walled offices, it will say, oh, my signal needs to penetrate through those walls and other obstacles, so it can't go as far. And so by selecting that, it's really changing the predictive model to actually force it to have smaller